The moment you cross a black hole's event horizon, your feet are already falling faster than your head. That gap in gravity, just a few meters of difference, is enough to stretch you into a thread thinner than a human hair. Astronauts call it spaghettification. It's not a metaphor. It's physics doing exactly what the name suggests, pulling every cell in your body toward a single point until there's nothing left that still looks human. But here's the thing nobody tells you. That's actually one of the better ways to go out here. Let's start with something almost as violent, but way closer to home. A neutron star. Take the mass of our sun, roughly 330,000 times heavier than Earth, and crush it down to the size of a city, maybe 20 kilometers across. Do that, and you get gravity nearly 2 billion times stronger than what you feel standing right now. Step onto that surface, if you could even call it stepping, and your body wouldn't just be crushed. It would happen faster than your nerves could register pain, faster than a single neuron could fire a warning to your brain. The magnetic field is where things get even stranger. Some neutron stars, the ones called magnetars, carry magnetic fields trillions of times stronger than Earth's. That kind of field doesn't just pull metal toward it, it reaches into the atoms themselves. The electron clouds inside your cells would start distorting long before your body ever touches the surface, stretched into thin cigar shapes instead of spheres. Your chemistry, the actual bonds holding your DNA together, stops behaving normally while you're still falling. You wouldn't just die on impact. You'd stop being biologically you before you even got there. Some physicists describe it less like a collision and more like your entire structure being unwritten from the inside out. That's the closest thing on this list. And it's still not the fastest way to die out here. There's also the spin to consider. Some neutron stars rotate hundreds of times per second, fast enough that a single point on the surface is moving at a meaningful fraction of the speed of light. Even if the gravity somehow didn't get you, the rotational forces alone would tear you apart within a heartbeat of getting close enough to matter. Now picture something slower, quieter. A crew heading to Mars months into a roughly 7-month trip with no planet's magnetic field left to hide behind. Once you leave Earth's protective bubble, you're soaked in galactic cosmic radiation, high-energy particles blasted out from exploded stars light years away, particles that punch straight through spacecraft hulls like they're barely there. Without serious shielding, that radiation starts breaking down DNA strand by strand. It damages the central nervous system in ways researchers are still mapping using data from missions that never lasted long enough to show the full picture. This isn't a death that happens in seconds. It happens over months. Memory loss creeps in first, subtle enough to miss, then motor decline, then a slow unraveling that starts long before anyone on the crew even notices something is wrong. By the time symptoms are obvious, the damage has usually been building for weeks. How much exposure is actually survivable on a real years-long Mars mission? Nobody's fully sure yet. Current safety limits are estimates, built on partial data from low orbit, not deep space, where the shielding is thinner and the exposure never stops. Some estimates suggest a round trip alone could use up a meaningful chunk of an astronaut's lifetime radiation budget before they've even set foot on the red dust below. And that's the part that should worry you. Let's go somewhere that looks almost peaceful. Titan, Saturn's largest moon, bigger than the planet Mercury. Thick orange skies stretch overhead, hiding the surface from view. Calm lakes stretch across the ground, catching what little sunlight makes it through the haze. Except those lakes aren't water. They're liquid methane and ethane, sitting at nearly 200 degrees below 0 Celsius. Step outside without a suit, and two things kill you at once. You suffocate in a nitrogen-thick atmosphere that has almost no oxygen. Your lungs pulling in gas that simply can't keep you alive, no matter how hard you breathe. At the same time, your body starts freezing solid in a fraction of the time it would take on Earth's coldest day, because Titan's dense atmosphere, thicker than our own, pulls heat away from you far faster than thin air ever could. You don't even need the vacuum of space to die out here. Titan does it on its own, with the sky over your head, ground under your feet, and rain made of hydrocarbons falling around you. Compare that to your own kitchen freezer, sitting comfortably at maybe minus 18 degrees. Now multiply that cold by more than double. That's Titan on an average day, and it's still one of the more approachable looking places on this entire list, right up until you try to take a single breath. Data gathered by the Cassini-Huygens mission mapped these lakes in detail, confirming methane rain, methane rivers, and even methane weather cycles that mirror the water cycle on Earth. It's a moon that looks, from a distance, almost gentle. Up close, it's simply built out of the wrong chemistry for a human body to survive even a few unprotected minutes. There's one danger that doesn't need a black hole, a dead star, or an alien moon. It just needs the sun in a bad mood. A coronal mass ejection, a massive burst of charged particles thrown out from the sun's surface, sometimes carrying the mass of a small mountain range at millions of miles per hour, can slam into a spacecraft outside Earth's protective magnetic field. Inside that shield, down here, we're fine. Outside it, on the way to the moon or Mars, a strong enough solar storm could deliver a lethal radiation dose in a matter of minutes, not months. This isn't science fiction. It's one of the exact risks space agencies are racing to solve before the next generation of astronauts leaves Earth's shadow for good. Every mission plan for a return to the moon has to account for a storm that could arrive with almost no warning, sometimes less than a day between detection and impact. There's no outrunning it once it's already on its way, and no thick planetary atmosphere out there to absorb the hit for you. And that risk is sitting quietly in the middle of every mission being drawn up right now, waiting for the wrong moment to strike. Some proposed solutions involve small storm shelters built into future spacecraft, dense, shielded compartments where a crew could huddle for the worst of an event. Whether that's enough to survive the biggest solar storms on record is still an open question engineers haven't fully answered. If you've made it this far, you already know space isn't just cold and empty. It's actively hostile in ways most people never think about. If you want more of these deep dives into the places in our universe built to kill you, hit subscribe, because the next one might be the most unsettling place on this entire list, because we haven't even gotten to the real twist yet. Go back to the black hole. Not all of them are the same, and the difference between them's the darkest detail in this entire video. A stellar black hole, the collapsed core of a massive dead star, maybe 10 times the mass of our sun packed into a point smaller than a city, is small. And that smallness makes it brutally intense. Cross its horizon and spaghettification happens almost instantly, violently, exactly like we described at the start. Your body is torn apart before your brain can even process what's happening. But a supermassive black hole, the kind sitting at the center of galaxies like our own, millions or even billions of times more massive than the sun, tells a completely different story. It's so enormous that the difference in gravity between your head and your feet, right at the event horizon, is almost nothing. You wouldn't feel stretched. You wouldn't feel torn apart. You'd cross the point of no return completely intact, and completely unaware that anything had changed at all. No pain, no warning, no final moment of realization. Some physicists even argue that, from the astronaut's own point of view, there might be no detectable crossing at all. Just an ordinary stretch of empty space that quietly becomes a trap. You just keep floating, keep existing, for what might feel like an ordinary stretch of time. Hours, maybe longer, depending on the size of the black hole. And only later would you understand you're not coming back. That the boundary you crossed without noticing was the last one you'll ever cross in your life. There would be no line to see, no signal to feel, nothing marking the difference between the moment before and the moment after. So here's the twist this whole video was building toward. The thumbnail promised you the worst place an astronaut could die. And by most measures, a black hole should earn that title. Feared more than anything else on this list. More than a dying star, more than a frozen moon, more than an invisible wave of radiation from 93 million miles away. But the neutron star rewrites you atom by atom before you even land. Titan freezes and suffocates you in the same breath. No warning label required. Deep space radiation erases you slowly enough that you might not even notice until it's already too late to reverse. And a supermassive black hole, the very thing that looks like the most terrifying death of all, might be the gentlest one in this entire lineup. No pain, no struggle, just a quiet crossing into somewhere your body will never leave and never even know it happened. Which death is really the worst? The one that tears you apart in a single instant, in front of your own eyes, or the one that never gives you the chance to see it coming at all?